Welcome to demo video for online lecture. My name is Jelena Tovarovic and currently I'm at my final year of PhD studies of psychology at University of Belgrade, Faculty of Philosophy. As you know, many students of psychology are eager to learn more about statistics, not just the basics, but more advanced levels. It is important to acquire knowledge, not just in mere explanation of the methods, but also in practical use. In this short video, we will be talking about the basics of structural equation models. What is structural equation modeling, SEM? Variables in SEM, the general structural equation model, symbol notation, and the path diagram. First, we'll start with the basics. SEM is a statistical methodology that takes a confirmatory approach to the analysis of a structural theory bearing on some phenomena. This theory represents causal process that generate observation on multiple variables. There are several aspects of SEM that set it apart from the older generation of multivariate procedures. It takes a confirmatory rather than an explanatory approach to the data analysis. SEM provides explicit estimates of error variance parameters. Procedures can incorporate both unobserved latent and observed variables. It can be applied for modeling multivariate relations or for estimating point and invert indirect effects. We'll talk now more about basic concepts of variables. In the behavioral science, researchers are often interested in studying theoretical constructs that cannot be observed directly. These abstract phenomena are termed latent variables or factors. Examples of latent variables in psychology are self-concept and motivation. Because latent variables are not observed directly, it follows that they cannot be measured directly. The researchers must operationally define the latent variable of interest in terms of behavior believed to represent it. As such, the unobserved variable is linked to one that is observable, thereby making its measurement possible. These measured measurements are termed observed or manifest variables. Within the context of SEM methodology, they serve as indicators of the underlying construct which they are presumed to represent. It is helpful in working with SEM models to distinguish between latent variables that are exogenous and those that are endogenous. Exogenous latent variables are synonymous with independent variables. They cause fluctuation in the values of the other latent variables in the model. Changes in the values of exogenous variables are not explained by the model. They are considered to be influenced by other factors external to the model. Gender, age, and socioeconomic status are examples of such external factors. In this example shown, depression is exogenous variables because there is no error linking to it. Endogenous latent variables are synonymous with dependent variables and are influenced by the exogenous variables in the model, either directly or indirectly. Fluctuation in the values of endogenous variables is said to be explained by the model because all the latent variables that influence them are included in the model specification. But example of those endogenous variables is social support and well-being. We all know that there is more to be said about the factor analytic model, the full latent variable model, the process of statistical modeling. But since this time is limited by this test video, we will shortly talk about symbol notation and the path diagram. Structural equation models use the geometric symbols. A circle or ellipse represents unobserved latent factor. A square or rectangle represent observed variables, A single-headed arrow represents the impact of one variable on another, and a double-headed arrow represents covariances of correlations between pairs of variables. Now we can begin talking about the path diagram. Schematic representation of models are termed path diagram because they provide a visual portrayal of relations which are assumed to hold among the variables under study. A path diagram depicting a particular SEM model is actually the graphical equivalent of its mathematical. For example, in this model, we see that there are two unobserved latent factors, self-concept and math, and the 7 observed variables. 5 are considered to measure self-concept, academic, social, emotional, family, and physical, and 2 to measure math, grades, and achievement. These 7 observed variables function as indicators of their respective underlying latent factor. You may be wondering, how did we construct this model? We will show it in Amos program. First, we need to click on Draw a latent variable or add an indicator to a latent variable icon. We click it, then we need 5 indicators. We click 5 times. We need then to rotate them because this is not how it's supposed to look like. Then we need math and 2 indicators with math. We again rotate. After that, we need to draw a path, single-headed arrow, from self-concept to math. If we want arrows to look prettier, we need to click a touch-up variable. We touch up. After that, it is important to name them. We name them by double-clicking. So we are naming now self-concept. Self-concept. After that, we need to name indicators. Academic self-concept, social self-concept, emotional self-concept, family self-concept, and physical self-concept. Now math. And this is math. Math grades and math achievement. Now we have errors linking to these indicators, but we won't name them one by one. We just click on plugins, name unobserved variables, and automatically they are named. In order to explain covariances, we'll draw it between E9 and E10, so emotional and family self-concept. Now we can continue with explanation of our model. So, associated with each observed variable is an error term from E1 to E7. And with the factor being predicted, math is residual term R1. There is important distinction between the two, but we will not discuss about it in this video due to being a test video of online lecture. In addition to symbols that represent variables, one-way arrow represent structural regression coefficients and thus indicate the impact of one variable to another. For example, the unidirectional arrow pointing towards the endogenous factor math implies that the exogenous factor self-concept causes math achievement. Likewise, the 5 unidirectional arrows leading from self-concept to each of the 5 observed variables, and those leading from math to each of its indicators, suggest that those core values are each influenced by their respective underlying factors, math and self-concept. These path coefficients represent the magnitude of the expected change in the observed variables for every change in the related latent variable or factor. It is important to note that these observed variables, so these 5 and these 2, they are typically scores or scores of the subscale. Or they can be item pairs or carefully formulated item parcels. The one-way arrow pointing from the enclosed error terms, so these errors from error terms, indicate impact of a measurement error, so E1 to E7, random or unique, on the observed variables, and from residual, the impact of error in the prediction of math. Now, we added the curve two-way errors. It represents covariance or correlations between pairs of variables. Variable errors are also latent variables because we cannot measure them directly. We can only make conclusions about them based on manifest variables. Thus, bidirectional error linking E3 and E4 implies that measurement error associated with emotional self-concept is correlated with the associated with family self-concept. We now shortly explained our model, but there is a lot more to be said about SEM analysis and importance of theoretical, methodological, and empirical use in studying relations among variables. However, this is a short video and this is a demonstration of an online lecture for faculty of. So thank you for your attention.